In problem number 3, we're asked to find the area of this shaded W shape in this grid down here. And we also need to remember that each square, each small square, so that's one of these squares here, is 100 square feet. Okay, so this would be like maybe a big, I was trying to imagine a story where a farmer was going to make some sort of crop art in his field, and he wanted maybe his Farmer Wilson, and he wanted to make a big W in his field, and so this is a big area. 100 square feet is one of those little things, one of those little squares. So let's see, a hint. I would say the key to this problem is not in finding the area of the gray W, but finding the area outside of the gray W. You can easily find out the area of this whole thing, the whole 10 by 10 grid, just by taking 10 times 10 times 100 for each square. And so you can find the area of the big square, and then it's actually easier to recognize that the area outside the W is made up of, actually let me get a highlighter. It's actually made up of a bunch of triangles, right? So we have that triangle. We have this triangle. We've got this triangle. And this triangle. And we've got this triangle over here. Oops. Alright, so we've got actually 1, 2, 3, 4, 5 triangles. And it's a lot easier. It's easy to find the area of a triangle because the area of a triangle is just 1/2 base times height. Okay, so if you recognize that you can just find the area of the triangles and subtract it from the whole big area, and you know the formula for the area of a triangle, then you've got it. So let's go ahead and do that. So let's just start with this triangle. We'll work left to right here. And this triangle has dimensions 3 down here by, now this goes all the way up, and then we know this is a 10 by 10 grid, so this is 3 by 10. So 1/2 base times height is going to be 30 divided by 2, which is 15. Okay, so that's the area of that triangle, and it's also the area of this one because we got some symmetry involved here, right? So this one's also going to be 15. Okay, and then we have 2 triangles here which are also the same, so let's go ahead and do those. This triangle is 1, 2, 3, 4, 5 for the base. Now we're calling this the base, but it's you know, triangle sort of upside down. It's pointing downward, so it's still the base. And then if we count the height, let's start it here at the peak. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have a height of 8. Okay, all the way down here to the peak. Okay, so if we take 5 times 8, that's 40, divide it by 2, and we get 20. So here we have an area of 20, and we know this is the same, so this has got to be an area of 20 as well. And then we get one more triangle down here. Here we have 1, 2, 3, 4 for the base, and the height is 1, 2, 3, 4, 5, 6, 7. So 7 times 4 divided by 2 has got to be 14. Alright, So all we have to do now is add those up and subtract it from the 10 by 10 grid. Okay, so the area of the 10 by 10 grid. Now I'm figuring area first of all just in the number of small squares. Okay, and then we'll have to multiply by 100 at the end. So we have 10 by 10, so that's 100 minus the areas of all these triangles. So let's see, we've got two 15s, so I'm just going to combine those and make it, oops. I meant to write a 3. 15 and 15 is 30. We have two 20s, so I'm just going to subtract a 40. And then we have a 14. Okay? And when we do that, we should get, let's see, we got 70, 84, so we're just subtracting 84 from 100, and so you'll get 16. Now, keep in mind that's just the number of small squares, so we have 16 small squares. Okay? And that's not what we want, though. We want the area in square feet, and each of the small squares is 100 square feet, so we just need to multiply that times 100. So 16 times 100 gives you 1,600 square feet. All right, and that's the answer.